Hello there, this is Hans Forschner with Navcon Engineering Network. In this video I present how to enter an industrial building in SoundPLAN version 8.2 and define noise sources on the facade and rooftop. The industrial building objective has a variety of options, so I'll go over that. So let me do a few kind of schematics here first. An industrial building is basically just like a building, right? The building can reflect. So if you have sources on the outside, they can reflect off the facade. It can also shield. So again, if you have a receiver here, we have a source here, then of course we have multiple paths around it, over it, and on the other side. All right. And then of course for the industrial building, we also have the option that this building can be a noise source. All right, and here we have multiple options. So let me go over this here. So we have either the option where we can assign a facade with a sound power level, sound power, or with an intensity level, and that would be again in dB per square meter. And we have like sub-elements, like a door, we can have a different intensity or sound power level for the door. Same for windows. So this is our first option. The second option is we have an interior level. So interior level, and that could be either an average or a peak, depending on what the objective of the project is. And so from this interior level we can have the program, so we define an interior level, and then the program, if I make a cross section, so if we here we have the facade, we have an interior level, and we have the program go through the facade, so we have a transmission loss through the facade, and we have some additional correction terms in terms of the interior level for the like a Q factor or C factor. So there are some additional correction factors, and then we have on the outside basically our intensity, LW prime. So here the very simple calculation would be LW prime is equal to the pressure level inside minus the reduction or transmission loss, depending, and then whatever correction terms we have here. The correction terms depend if it's a very reverberant or very reverberant or absorptive room. And the third option is we actually predict, so the interior predict the indoor level. In that case we are actually defining some interior sources here, and we are actually predicting, so we are actually doing an interior prediction of that interior level, and then again we are assuming the transmission loss or assigning a transmission loss for the facade or the element, and then either assign a correction term or let the program calculate the correction term. And then again, for all of these situations, then the industrial building is then also a source. So noise is being radiated from the roofs, from the walls, from any elements in the facade, and is basically then a sound source or noise source. So let's get started with the software. I'll go into the Geo-Database. Again, that's where we develop our noise model. I have a metal fabrication place here that I'd like to enter. It's a relatively simple square building, so I open up this situation. We have a few, let me show the 3D view. So we have a certain community, the industrial building goes right in here, and of course we have noise that will be radiating into the community. All right, okay, so let me turn on the site map. We zoom into the area. So the main sheet metal place is right here. I have the industrial object here, an industrial building or room input. And in terms of options, I set it up that on the first coordinate I will get the object parameter input, so I can define the name and all that. So it will pop up on the first coordinate. And then just to make sure that I want to create a rectangular building, I'll just turn on the rectangle angle modus. So I'll get started with this coordinate right here. I digitize the first point, and this is sheet metal fabrication building. The height of the building is 6.5 meters. The reflection loss here for the exterior sources, if we have any exterior sources, is 1 dB. So again, the reflection loss of 1 dB is equivalent to about 20% absorption and 80% reflection. This is an overall reflection loss, so this is not frequency dependent. And then here, of course, we can also float the building if the building would be elevated off the ground. That would also mean, in terms of the shielding effect of the building, the path would be not only over, around, but also underneath the building. So just food for thought on that. For some of the interior calculation, we would have additional information to put in here. At this point, we don't have that. All right. So I'll click on the bottom right corner on this green check mark, and the first point is in. I go to the second point, and then third point, and at this point I can just double click and the program completes the input. Let me highlight this building. So here you can see there's the building. And if I turn off the site map, here we can see the building. All right. Now, one thing I notice here, this building is not quite overlapping with this building. So if we wanted to have a shielding effect that goes around both buildings, we would need to make sure that these buildings overlap slightly. And by overlapping, the program will know these buildings are connected, and the shielding would go all around. The horizontal shielding goes all around both buildings. All right, so let's open up this building. And so again, here we have the main general property window. Then here we have the editor. So I'll click on the editor, and here we get the view with, first of all, on the left-hand side, ground floor, facades, roof. If you don't see the ground floor, that's probably because you don't have the interior noise module. If you don't have the interior calculation, you would only see the facade and the roof. In the center, we see the projection of whatever is highlighted in terms of the facade. So right now we are looking from the outside. So here we see the north arrow on the top right corner. So this is the south side. So this is the projection of the south facade of that building. If you remember, that building was close to the property line. So here we have, this is the property line. So here is probably where we have the garage doors for this, or the openings of the doors in terms of getting into the building. Let me go back. So what we can do here is, let's say from a worst case standpoint, there are roll-up doors that are open or closed, and so we could define those as area sources. So I have here multiple options here with defining sources. So this is the facade, the entirety of the facade. We can call it, this is the south wall with doors. And what we can do here is we can assign sources on this facade. We can either enable the entire facade right here with this little check mark, enable a source, and then the entirety of the facade is a source. The definition here would be then under outdoor area source properties. So when we select that, it highlighted now the building facade with this orange color. We can group it. So if you have groups, you can again group it to, let me create a group, sheet metal fabrication. All right, we assume an interior level here, right here, and we assume the interior level, again, we can, let's say we assume an interior level of 100 decibels, and we assume this to be some sort of a concrete wall. So now we have the entirety of the facade defined with an exterior intensity level of 41.3 decibels down here. And now inside that facade, I want to add 2 doors. So I'll turn on this area source right here and define an area source. Yeah, first of all, for this door, so that's my first door. We can check on the geometry. So this is about 4 meters wide. All right, and it starts at this coordinate, and so it's 4 meters tall. Actually 4 meters wide. Let's make it 4 and 8 and 8 and 4. All right, so now we have a basically a square rectangular door opening, and what we'll do here is we assign a open either a door. Let's say we can assign a aluminum door to this. Looks like that transmission loss for that aluminum door is not meeting all of the frequencies, so let me extend this. So go to the transmission loss of that aluminum door, and we go down to 50 Hertz. So maybe 2 dB reduction, and then go up to 10 kilohertz, and then here we'll just go with 12 dB across. So we are extending frequency range of TL to 50 Hertz and 10 kilohertz. All right, I post the change, I accept that, and now I have data for all those frequencies. So this would be an aluminum door with the door closed, and this would be our first door closed, and then we can take this door and, for example, we can duplicate that, and we duplicate that in X direction 2 times. 10 meters every 10 meters. And so that was probably too much. Let me just remove this one. Maybe just do it like this here, and then again duplicate, and we'll do it 5 meters. All right, that was not enough. All right, maybe something like this here. All right, so now we have 3 doors, and what I can do is I can open up these second and third door. So this door is open, center, and then third one open, and this is east door, for example. And to make it open, we select the opening, which is 0 dB reduction, and then here we have also 0 dB reduction. All right, good. So this is just again one facade, defined in 2 different ways, with an interior level going to the outside. We can of course do that now for all the other facades as you go around this. So this here is the east facade, and then here we have the north facade, and maybe on the north facade we have again we can assign the interior level with 100 dB, and the sheet metal, one of those reductions. And then so this would be, for example, the back of shop. All right, and then within this here we could, for example, put in a window, right? So here again, this is the source, and then we can define a window across, and so this would be north facade with window, and then in this case same pressure level, but then we just use some sort of a double glazing, for example. All right. Now for the roof, the same thing. We can enable that as a source, and this is some sort of a light roof. And then here again we can define the interior level with 100 dB, and we can define say some sort of a sheet metal with mineral wool on top of it. And so that's kind of the roof here. Now let's say we had some sources here on the roof, and let's say these could be HVAC systems. So let's maybe put a HVAC system on top of the roof. So we put a point source here. It's maybe 1 meter above the roof line, and then this could be just a sound power level that we assign for a HVAC system. All right. Actually, let's go some sort of a HVAC unit. All right, and okay. Now with any of these, let me just, these are already sheet metal, so I just assigned them to the group. As you notice, maybe on these sources, they are all defined as running 24/7. So if you have a different operation that is, for example, just during the daytime, let's maybe open that up and see there's a daytime operation, metal fabrication, so we could use that. And let's say if we had all these sources here and we want to let me just change this HVAC. let's say we have all these sources and we want to assign them all with the same spectrum or the time histogram. We can look at the sources and so here we have group histogram and then daytime operation, and then let's see, daytime operation, there we go, and then we can assign that to all of them. All right, good. So again, these property tables are very helpful to make everything consistent in terms of the input. You can double check that you assign them all with 100 dB, that we have different spectral assigned in terms of the interior level, what the transmission loss is, the assigned transmission loss. Here we have the windows, the openings, the doors. This is the roof, and then here we have the two walls. All right, I'll close this window and we can take a look at that building in the 3D view. So here we can now see the building, the roof and the facades that are defined as sources. Here we can see the window, the doors, and then of course we see the HVAC unit here on top of the roof. This concludes this video. Thank you for listening. Have a great day. Stay safe.